think we can start at least presenting Piero, and welcome Piero to this Tech Talk at Pi School. I'm really happy that you joined. Actually, Piero, it's now in the States at the University of Cincinnati, but it's from Italy, and he studied with Marcello. By the way, we discovered that they were studying, I don't know if really together, but in the same university. Then maybe you can you will explain with Marcello Politi, which is one of our fellow of session 10. I've never met Piero live, but I don't remember how a couple of months ago, maybe 3 months ago, 2 or 3 months ago, we knew each other. We met on LinkedIn. I really don't remember why, but maybe you can tell.
Yeah, it was like actually like on my article or something like that. So I got curious and I added you on my network. I think it is all started.
Exactly. Okay, yeah. That was. Then we had a call, and I told to Piero about Pi School in general. Actually, at the moment, we were searching for a mentor for a specific challenge. But then we realized that maybe that challenge was really specific and was not sweet. Piero is an expert, but on another field, and we find maybe another researcher. We find Timo, which is a professor in Max Planck Institute in Munich, but we stay in contact, and so we decided, also talking with Marcello last week, to invite Piero for this tech talk. So I will stop here, and maybe I will add something later. I will leave the floor to Piero so you can introduce yourself. And Piero not only is a PhD candidate in machine learning, but in addition is also a writer, blogger, a writer on towards data science. So he will also tell us something about this, let's say, activity. Okay? So, Piero, go ahead. Thank you.
Okay. Thank you, Cristiano. Thank you all for being here. I will start presenting because in my presentation, I actually have everything that I think we need to say about me as well. So, okay, give me just 1 second. Here I am. So Google crashed. Sorry. Okay, can you see my screen now?
Yes.
Yep. You see yourself in the loop right now. So, okay. Here we go. Again, thank you for being here. Thank you, Cristiano, that invited me, and thank you everyone for being here. My name is Piero Paialunga, and I am a PhD candidate at the University of Cincinnati in Aerospace Engineering and Engineering Mechanics. As Marcello said, I use artificial intelligence and machine learning a lot. I have a bachelor's and master's in as Cristiano and Marcello said. I use machine learning a lot as I study. Again, I study aerospace engineering, but in my master's degree, I used physics a lot because I have a master's and bachelor's in physics, but machine learning and artificial intelligence as well, because I did a master's degree in physics of complex systems and big data. I am a technical writer as well for towards data science, so we will talk about it as well. This is the schedule of the presentation. I will tell you a little bit about myself, then I will discuss about my research, that is non-destructive testing. Then we will talk about where artificial intelligence plays the part, and I think that is what actually sparks your interest because you're a machine learning guy. So I will talk about a little bit of technical details about the machine learning part that I'm developing. And then I will talk about the technical writing in terms of machine learning as well. That is right now my second job because I'm starting to get paid enough to make it become a second job. Of course, my first source income is the one as a researcher, but I feel that it may be interesting to tell you how it can actually become something more than you can do if you want to write and talk about machine learning, as I bet you all guys are passionate about machine learning. And then, of course, we will have the final Q&A, your questions, and I'll be happy to give you, hopefully, the answer. So this is me. I have a bachelor's degree in physics, and this is me in one of the sleepless nights while studying for my bachelor's degree. The picture below that one is me eating a Burger King meal after my master's degree thesis, which I discussed in May 2021. I am a top writer. I started writing top writer is not because I say myself that I'm a top writer, but because Towards Data Science says that I am so, in the sense that they give you a list of top writer in each topic. I'm a top writer in artificial intelligence and ironically climate change, because an article that I wrote about climate change became viral on Medium. Right now, I'm working again at the University of Cincinnati, Ohio, USA, in the Department of Aerospace Engineering and Engineering Mechanics. You could probably see that because right now it's morning, while in Italy it's almost night. So these are my skills. I like to tell stories. I was always the one that wrote reports when I did, I don't know, in middle school, high school, and even in the bachelor's degree. And I keep writing stories a lot in my daily routine as a technical writer, and of course in the research papers that we're writing in our department. Of course, I am a machine learning guy. I work every day with data, and the research that I'm actually doing is all about data, as you will see, and all about simulations and technical and let's see, simulation and surrogate modeling and damage detection. I do a lot of things that regards actually engineering mechanics and aerospace engineering, but everything is related to machine learning, but it will be clear later on. And again, I do modeling a lot because I'm not as skilled as proper software engineer, I would say, in terms of how I work with the computer. There are tons of guys that are better than me. What I am good at is combining science, combining engineering, combining physics with machine learning, because these are my two backgrounds. I am a physicist and I work with data every day. So I'm good at modeling, as the name shows. Let's talk about what I do. Non-destructive testing. What does it mean? It's a testing, of course. So you can say that this is what I do. I test materials. And it is non-destructive. So the comparison that is good to understand what non-destructive testing is when you go to the doctor. Imagine you go to the doctor and your leg is hurt, and your doctor wants to understand if your leg is hurt because it's broken or not, or whatever. And imagine that to test that, to see that, the doctor breaks the other leg. It wouldn't be ideal, right? So when you do a test on a person, the test has to be non-destructive by definition. And we want to do the same with a component, because if you want to understand if, for example, I don't know, a wing of a plane is cracked or not, you don't destruct the wing of a plane 2,000 times, 10,000 times, 1 million times, just to get a distribution of the fatigue, right? It's very inconvenient. So what you do is you do non-destructive testing. That means that, for example, if you consider this component, you have two sensors that are an emitter and a receiver. What you do is you send ultrasonics and analyze response spectrum. In this case, you have a crack, and this crack actually results in an increase in amplitude for the for the transmitter, and a decrease in amplitude for the receiver, because you don't have the full reflection, but you have a little bit of reflection here, so it increases the amplitude here, and a little lower transmission here, because some of the energy goes back instead of reflecting back to the transmitter receiver. Sorry. So basically, the idea is analyzing the spectrum and reveal damage. How do you do that? So imagine you have this current signal right here, and imagine you have a baseline. Now this current signal is a signal of a real component, and so what you want to know if this component is damaged or not. The baseline subtraction, or optimal baseline subtraction technique, is the one that you do. It is not machine learning at all. You just take the signal, take your baseline, that is probably the first signal that you have, or the signal that is closest to this one, maybe in terms of mean square error. You do the difference, and you have, for example, this little guy here. And you take this little guy, and you see that this little guy is way larger than the other residual. So in this case, you won. You have damage. You know that there's damage there, and you won. You can actually say this component is damaged, no doubts about it. How can you actually do that? Well, you take, again, this response signal, you do the Hilbert transform. It means that you take only the envelope, and then you use a fixed threshold, and you say, okay, everything that is above this threshold is the damage. So for example, here you have multiple damage. You take this threshold and say, here, here, and here I must have damage because it's above my threshold. Here you take this threshold, but you don't have any damage because everything is below your fixed threshold. So you use a single line to discriminate the damage. Now, does it work? Is it really the best way to do it? Of course, if I'm here talking about PySchool or talking with PySchool, it's because it's not really efficient, and it's because machine learning can do better, as I will show you. So imagine that you have the current signal and you have the baseline signal, and you do the difference, and you don't get this. That is super cool, but you get this. You're not happy, right? Because, for example, you may test this algorithm, so you may know already that in the current signal there is damage here, but you have a bunch of other residual that just mess up with your signal, that are all these little guys here that are larger than the damage itself, and that's not good. We're sad. Why do we have this? Because there is the so-called elephant in the room. That is the temperature, as I will show you. So the dataset itself has a strong dependency most of the times with the temperature. So if you consider all these signals right here, and you plot each signal with the temperature at different index data point, you will see that there is a clear dependency. Sometimes it's linear with some noise. Sometimes it's not even linear, like here, or here it looks like the Nike logo. So you have you know that you have a kind dependency of the signal with the temperature. So that's why we kick in with artificial intelligence. What do we want to do? We want to take a signal at a given temperature and create a model that gives you the decision that the signal is, the component is damaged or undamaged. That's our main goal, our main idea. Of course, we want to use the temperature as input, and we want to have a machine learning model that generates a new signal. So let's say you give me 50.61 Celsius, or as they like here, Fahrenheit, and then you have this signal as an output, that is a whole signal out of a single temperature as input. So input is monodimensional, signal is 2048 actually dimensional. This is the same slide I showed you before, but there is now a bonus, that is this part here. The dependency that we have with the signal and the temperature is going to be used to train a Gaussian process regression method. I will go fast on this because I bet that that you guys know what I mean about it. But generally, you have all these lines that I show you here, and you feed a line, and this line is linked with a kind of uncertainty. The idea that is behind this, and again, I will go quick because I bet you know about it, is that the signal follow a functions that is disturbed by Gaussian fluctuations around these functions. So the idea is that the process that you see is actually one of the stochastic variations, stochastic meaning distributed in a Gaussian way, so a Gaussian stochastic process around the mean. So the mean function is what you usually get, but you may get something that is predicting again with a Gaussian uncertainty. And of course, the most simple idea is to use a radial basis function. So what it means is that if you have a signal that's 20 degrees and a signal 19 or 21, they're basically, they contribute a lot because they're basically the same. But there is a part of white noise kernel function that says, okay, but if I have exactly the same temperature, it's not really true that it is 1. It is actually a noise level. Of course, as you know, these parameters, this sigma right here or this noise level are both trained. So there is an optimal hyperparameter tuning of this part. I don't know. It's probably more than. I don't know if it's correct to talk about parameter or hyperparameter, but it's still a parameter of the model that you train to get your best. It's probably a parameter. It's not hyperparametric. So you take this Gaussian kernel, and there is actually RBF plus white noise, and you train your model. Let's see how it works. You have okay. So let me clear that. What does it mean? It means that, for example, if you have a temperature that is 25 and this is index 400, you do this for all the indexes from 0 to 2048. So at the end, you're able to actually recreate a signal because you train 2048 GPR models. So you train one model per data point. Once you've done that, you're basically able to create new signals because you have 150 quasi-random temperatures, and all this temperature gives you for each index data point as the plots that we've seen before, and you have the GPR model that is trained and is now ready to work at any temperature you want. So what you do is you use 150 or 12 or 20 or 30 equispaced temperature to create a new GPR mean and variance. Now you have a new measurement. Okay, so let's say you have all your bank of data, you have this new measurement, and you do a thing that is similar to the one that we've seen before with OBS. So you take the optimal baseline subtraction. So you take the one of these that has the lowest MSE, and then you have your optimal signal. So I bet that what you're thinking now is, what is the difference? I mean, we did OBS when we have our signal and we take the optimal baseline. Now we have our signal and we take the optimal baseline. So what is this all machine learning stuff you're talking us about is? Well, you're right, except for the fact that now we have boundaries. And boundaries are not fixed lines like they were in the traditional method. Boundaries are learned. Boundaries are something that you get from the statistics of your signal because it is how GPR works. So having the statistics of your signal, you may see, for example, here, that you have that the signal is out of boundaries, okay? And here you can say, here we have damage because we have 99.7% confidence boundaries all over here. So this signal is actually more unlikely to happen than 99.7% of the cases, which is absolutely a good indicator that here we have damage. And actually we knew because it is a controlled damage done. So we actually knew that here we had damage. So the idea is that I'm now using these boundaries that are not fixed lines. For example, here you can see that the boundaries are larger. Here you can see that the boundaries are really, really small because this is the first reflection, so you're supposed to know exactly what it happens there, but you don't know anything about what it happens here because this one looks more like noise or more like nodes that interact with each other. So it is something that is learned. It's not a fixed threshold. This is the machine learning thing, and I'm really hyped to talk about it because I love GPR, I love machine learning, and these things are actually the things that actually makes me happy. So right now, this is the difference. And again, this line is beautiful. Is when I saw this, when I was able to actually print these results, I was out of myself, because we have the OBS fixed threshold method that says, okay, everything that is above is damage. And you can actually get the damage if you take the right fixed threshold, but you get a bunch of false positives because you say that all these things are damaged, but they're not damaged at all. So this is not good. Now, I'm not cheating. It is the same signal and it is the same damage. And this is what happens in terms of the boundaries. Bam, the signal is out. While everything else, you can see that is completely in. Actually, it's really hard to see it here, but here you can see that if you use 95% of boundaries, you're actually doing things good, because now you start from a model that says, if we have damage here, we have damage everywhere, basically. And you get to a model that say, you have damage there, because it's very unlikely that there the signal is that large. And this is what happens in terms of area under curves. So of course the model is parametric, because I could try to say 95, 96, 97, 98, and this is actually the upper parameter part that I was confused about for a second earlier. You can change the value, the threshold value, and you can see of course what you would like to have is an area under curve of a rock curve that is a square, as you may as you may have studied. I'm sure you know what I'm talking about. So if you compare what happens with OBS that use fixed thresholds, so you change the threshold from here to here and you have other rock curves, you get that the area under curves are incredibly better, from 79 to 88, 90 to 97, 63 to 54, and I'm actually plotting the box plots. So I really hate when in the research paper I found the mean, because if you tell me the mean, you're telling me nothing. If you tell me the mean, but your standard deviation is huge, well, the method is not reliable. But you can see that this is not the case, because, for example, if you take 88, the minimum value here is 70, while the minimum value here is 45. So we're doing better. We're actually doing better. Okay. Probably it was a good idea actually to add a Q&A here before I go on, but I didn't tell you before, and it was actually important, so I'm sorry. If you have any question, don't wait for the end of the presentation. Just ask me the question straight away. It is not a problem at all to interrupt me. So right now I will change to a slightly lighter topic, that is technical writing, but I would be happy to answer every question about everything that I'm talking about so far. So interrupt me whenever you have questions and doubts. Okay, technical writing. When I don't work, I work. What does it mean? It means that I work every day on machine learning, and I work on machine learning in terms of my research as a researcher on the things that I showed you before. But in my spare time, I still work with machine learning, and I write articles about machine learning and data science. This is me writing an article. This is me writing an article as well. And these are a bunch of articles that I've written all over these 2 years. Yeah, this is how I started. I started talking about bipartite networks, and it was because in 2020 I had this course, this university course about bipartite networks, and I started with an article that says bipartite networks will tell you what you truly desire. I don't know if you guys have watched Lucifer on Netflix. It's a really good show, and it is the punchline of the main character is tell me what do you desire, because the main character is the devil. So I used the tricks, but this article was, it was good. 648 views, and this was my earnings. So I bought an ice cream with that. Not really an ice cream. Some candies probably with that. And this was my first article in 2020. This is the articles that I'm writing now, and these are the numbers. So of course, it went better even in terms of the earnings. I got $300 from this article. I got more from these twos, and I got something similar from the others as well. These numbers are actually increasing. So these articles are doing really well. And I am now at this point. Of course, I can do better. I will try to do better, and I will try to as Will Smith said after the Oscar, he's a work in progress. So if Will Smith is a work in progress, I am a work in progress as well. I try to get to do better, but I think that I'm growing in the good way in terms of the articles that I'm writing. So I want to show you how I did that. This is why I had said that I was a top writer, because Medium gives you awards as top writer in the topic of artificial intelligence, climate change. Climate change is because, as you see, weather forecasting with machine learning is the most viral article that I've ever written. How do you grow? Consistency, for sure. It's about writing a lot of articles. It's about finding each week something to talk about. Of course, you gotta like what you gotta like writing. I feel that it's not really necessary, like strictly necessary, to be to use LinkedIn and to use connections and to use Medium and to write articles and to have what they call personal branding nowadays. But I feel that it could be something useful, because for example, for the University of Cincinnati, when I applied for this university, it was the first thing out among of hundreds of candidates. The fact that I wrote the article and the fact that they were going viral, it was a thing that actually made the difference. But anyway, to get these numbers, what you have to do is exactly what I showed you. You start from articles that don't go too well, and then you keep writing, learn more, and then you increase your numbers. So let's talk about Towards Data Science. Towards Data Science is here, as you can see. Me scrolling is a website, of course, and it's actually more than a website. It is a page on Medium. The people that looks towards data science are a lot, because they have 628K followers. So it is actually a good place to write articles, because a lot of people read them. Of course, we don't talk about football, we don't talk about NBA, so I don't expect ever to get 60 millions, 100 millions of views, of course. But as you can see, if you have 20K, you still get $300. So it is a good thing to write on Towards Data Science with these numbers, because you can get promoted using their people, basically the people that follow this page. It is actually one of the most important, if not the most important blog. I'm sure that when you have questions and when you have stuff that you don't know about machine learning, you go to Towards Data Science as well, because I do, to learn more and to solve my problems. So is it the same of Medium? So Medium and Towards Data Science, what is the difference? This is the question that I get asked a lot. They're not the same. They're not the same because there is a difference between these two, and it's a subtle, but it actually is a difference. Medium is an online blog, and everybody can write a Medium, and everybody can earn a Medium as well. You set up your Stripe account, and you start to get money on Medium. But if you start and write your article on Medium, only your followers will see the article, and of course, it is on the Medium page, so everybody can Google and look it up, but it's very likely that they find your article on Medium, unless it goes viral, because yeah, it's like posting something on Facebook. Of course, it can go viral, but if you have 50,000 followers, it has more probability to go viral rather than if you have 4 or 5. So everybody can write on Medium. This is really important. You can start writing on Medium and then try to submit the article on Towards Data Science. There is a page on Medium that has a lot of followers, as I showed you, and each article has to be accepted. There's not only towards data science, so the big one is analytics media that I have articles on as well. There is geek culture that is a part of the startup, that is a big page on Medium as well. There are a few pages, so you can actually submit the article to them. The first article, you have to go to their page, then you become their writer, so they keep you like in a short list, and you can add the article and feed the article directly to them. There are some technicalities I don't want to bore you about, but you have to be accepted to write in towards data science. It's not like everyone can write there. I mean, everyone, of course, but they have to accept your article. And of course, you earn money from towards data science as well. You actually earn more money because usually you have more stats, so more people, more likes, more things. So how do you write articles on Medium? I collected some tricks. The first thing is to the first technical trick. It is actually, this is in the reverse way, in the sense that these are the technical ones, and then I will talk about the more philosophical ones, I would say, the more ones about the why you're writing, what you should write, and stuff like that. But the first thing to do, very practical, is to start the article with an image. It is something that is always been done, and it is catchy, because if you see an article and it has an image, you're, of course, I don't have to explain you that if you see an image, you are more tempted to click on the image and to go to the article. Unsplash has these articles, this image where you just have to, so free copyright, free use, you just have to cite the author of the image, but you just search for them, type in, find the image, and then, for example, if you say that I'm doing damage detection, I will stop typing damage or detection or test doctors. I will settle something like that, and then find the images. So Unsplash, really good site, highly recommended. You have to attach the code. I use Jovian. Of course, you can use GitHub, or you can simply do command option 6. I think that is the option on Medium to attack the code and to write the code like a snippet code. But Jovian is really cool, because when you download Jovian, when you do pip install Jovian, then you have Jovian on your notebook like this. So you have actually a button that you can click, and then it brings you to a page when you just can attack your code as snippet, and you can it has the option of copy to the clipboard, and it shows the output as well, which is amazingly good. So Jovian, I recommend it as well. How about the title? The title has to reflect what you're doing, of course, but as you saw, the first article was about Lucifer Morningstar on Netflix. So I was trying to be really, really creative and catchy and do some funny thing and be hilarious and be the smart guy. You don't need to do that. The articles that are viral on Medium has really, really simple and direct titles. So these are the titles of one of the most viral articles that I have: weather forecasting with machine learning using Python. Very simple, 50K views. And the thing that you need to do, of course, to write about something is to create a story. You have to have a story on your mind. For example, one article that is, let me go back for a minute. No, it's not here because I just done that. It has like, I think it's exactly the 6th one or the 7th one. I was at a bar. I was at a bar hanging out with my friends, and I'm starting to write something that is about Markov chains and modeling Saturday nights using Markov chains. So the article is called Saturday Night Modeling Using Python. You have to have a story. You have to have a thing why you write that. For example, this one is a good example as well. I love music, and I really love Spotify. I use Spotify a lot. Spotify for podcasts, Spotify for albums, Spotify for everything. And I love the Spotify Wrapped AI that I get every year. I'm so excited to see what happens every time that I get to the end of the year to see the Spotify Wrapped. So I actually do a reverse engineering Spotify Wrapped AI using Python, and you can write the story. You can. I mean, I write the truth. I don't like to make up stories, and I'm not really convincing. I'm a terrible liar. So I just say the truth. I say why I wrote the article, what is in my mind, and I try to get straight to the point. The articles are 5, 4, 6 minutes long. This is the average. Don't write 30 minutes article because it's really hard to follow them. And then, of course, you don't have to be obsessed about money or fame. I mean, you're not going to be Cristiano Ronaldo because you wrote an article. You're not going to earn millions of dollars. It's actually hard to make it become a proper first job because you need to stay on track and write, I feel, probably one article per day to make it actually become the first job. But the first thing is that you need to enjoy what you write. You need to enjoy doing what you do. Yeah, that was the last question. That was the last slide. I felt that I went really fast. I'm sorry. When I talk about machine learning, I get hyped and I speed up a little bit. So I'm sure that everything I said wasn't really that clear in some parts. So I'm happy to have your questions and give you some answers.
Yeah, hello Piero. Sorry I was late. Marcello here.
Oh, Marcello.
I'm fine, how are you? So I have a question about the last part, about the Toward Data Science blog. So I read a couple of your blogs, but I just wanted to ask, how technical are your blogs, like formulas, maths, you know?
Yeah, I try to get the idea, but I usually report to people that wrote articles that are more technical than me. Sometimes because I don't write, sometimes it's because I don't write on things. Of course, if you talk about, I don't know, Gaussian process regression, I feel that I know a lot about it. But if you talk to me about attention method for deep learning in recurrent neural networks, of course, I'm not the best at it. You know, there are people that are better than me. So if I have to use recurrent neural networks, I write what recurrent neural network are. I explain the backpropagation, I explain the sequential part, I explain some basic ideas very lightly. I don't use formulas. And I refer to articles that are actually more, focused than me. You know, for example, if there is a guy or even Wikipedia or a TensorFlow documentation or sklearn documentation that brings you to Wikipedia, something that is very light, then they can understand at least broadly what they're talking about.
Okay, I got it. Thanks.
So I got a question from Shady Nagy. I'm sorry, I must say it right. Hi, Piero, thanks for this session. I have 3 questions. How to choose the topics I feel like this stuff a typo to write about. Sometimes I have to be honest. Sometimes I try to write at least 4 articles per month, 1 article per week. So sometimes I don't have the proper idea. I just go to Kaggle, look at a data set, find inspirations there, and take the data set. It is really important. I didn't tell you that, but it is important. Towards data science, don't accept data sets that are not free use. So they pay a lot of attention. So if you use a data set, they need to be sure that the data set is public and ready to use. That's why I use Kaggle most of the times. So sometimes I do that. Sometimes I have some kind of inspiration. For example, Spotify Wrapped. I was sitting in front of my computer looking at Spotify, and I just got curious. Or for example, once I was doing a presentation, I dragged an image on my PowerPoint, and I saw the little PowerPoint sentence that is like, this image is a picture writing stuff. And I was like, okay, so let me try to understand how Microsoft PowerPoint AI works. So sometimes it's daily things. Actually, most of the times it's daily things and things that happen to me, and I'd be like, okay, you know what, I'm gonna spend 2 hours, 3 hours, 4 hours and write articles about it. Sometimes it's because I want to keep doing it, so I want to write 4 articles per month. So if I don't find inspiration, I create inspiration. I go to Kaggle and I find the articles to write about. So yeah. I have another question from Shelly as well. What is the best length of each articles? I try not to be. I don't really see the number of words, but Medium tells you the average, the estimated reading times, and I never exceed 5 minutes, because at the end, guys, if you find something articles on towards data science, you don't want to read 30 minutes articles. So we have in this frenetic world, we don't have much time, so it's better to get straight to the point and tell me what it is all about. It is better to choose new topics or point. Okay, Serdar, I am coming to you. Is it better to choose new topics or points? What do you mean by the last question, Shadi? Okay. Okay. While we wait, Serdar Altan, I have a few questions, rather not right here.
Yes, Piero. First question is that about the technical writing thing, and you mentioned towards data science, but there are other avenues aside, apart from the financial considerations. For example, which avenue is most productive? For example, as far as I know, GitHub has a blog, and you may have your own website, and also Medium and towards data side, and KD Nuggets also there's an option. So among all these, which one do you think that is most productive and the most optimal way for the data scientists to write articles?
Well, there are a lot of actually, as you said, it is a good question, because there are a lot of options. I feel that Medium is the best one, as you don't want to spend too much time on that. I mean, you have your work, you are a researcher, you are a machine learning engineer, you work in a company, and you, as a machine learning engineer, you don't have much of a free time anyways. But when you have free time, you want to write stuff you like to talk about. You don't want to get into too much steps, before having your articles out. So Medium is really easy, because you can go to Medium right now. I can show you actually. So if we go to Medium, you do this, and then you start writing. Then you go on Unsplash, and an image. Let's say again, I want to talk about damage detection. Damage detection is a shitty title, but let's say about, this one could be a good one, for example. And you just do a very simple thing, that is like download the image. And I mean, Medium is super easy to use. You take this image, then you find this, and then you start saying, and you have it, and then you start with the title. That is, okay, let's say damage detection using machine learning. Python. Here's how to do damage detection for MDT. And you start writing your articles. Then one thing that you can do is, for example, again, I will show you. I don't know if it actually answers your question, but it is interesting for me to, for example, this is one. I have Jovian right here. Exactly. So I go here and I do this. And it shows the code. So it is really simple to write on Medium. That is why I recommend that over GitHub and KD Nuggets and everything that it may be something that needs to get accepted, but it may most of the times as I try KD Nuggets, I try GitHub, I try a little bit of them, they're a little more a pain in the ass than just write this article on Medium. And I mean, it's easy to be a little more pain in the ass than this, right? Because you saw how much it takes to actually write an article about it. And of course, you need to have something to say, because this article, for example, will sell probably $2. But the way of writing the articles is that easy. So that's why I recommend that over other publications that you may try. I don't know.
Yeah. Thank you. And the second question is this: we are working on a project here at PySchool, and we just want to create a profile, and this profile about the career. job, human resources.
Okay.
So this about the text generation, and I was doing some research on the internet, and I came across your article on Towards Data Science, this Stephen King text generation.
Mm-hmm.
And
Yeah.
well, this is the situation that, for example, we have things like this. Let's say, okay, I am an economist. I live in Spain, and I'm writing articles on Towards Data Science. So this is an item-based information, and we input into the model, and we want to get some profile. So let's say the 3 or 4 sentences we will input into the model, and we want to get a text like a story, which consists of 8 to 10 sentences. So your model can handle that, or maybe we can use LSTM because you have used their GRU, and maybe we can use LSTM. But anyway, I mean, your model actually can answer our question.
So tell me again, what is the input of the model?
You use the GRU?
No, the input. Like, what is the?
No, the input is about actually is the values like independence and for independence, for example. But that's a description, 1 sentence description, short sentence, and the other one is, let's say, recognition. The other one is achievement. So we have 3 or 4 sentences like this, and we want to input into the model and want to come up with some profile in this story. Like, for example, as I just said, okay, this person lives in Spain and he writes articles and so on and so on and so on. So all these 3 or 4 sentences will be converted into an 8 to 10 sentence story.
Okay. I feel that you should. I feel that you should change my structure a little bit, because my structure was like, for example, the Stephen King. I did another one that is very similar. That is about the research paper. So, for example, I have. While I was working on my research paper and I was finding the title for my article, I recognized that all the scientific research paper are something for something. This is the structure. So it was really easy to use a deep learning neural network to get the input. So, for example, I wrote machine learning, and then I let the network continue. Okay, using an R and N. What you're doing is slightly different because you want to get the input, process the input, and generate something more. So it is not like you want to. It is not like you want to continue a string of things that has already happened, but you want to generate new things out of certain things. So I feel that LSTM could be a good way, but you may have to change the structure a little bit, because it's not something that is really step by step, but it's more analyze this, help me that. So it looks more like
Yeah, and the corpus you trained on is, of course, the Stephen King books. And what is the related corpus that we can find about this career advice and human resources and that kind of thing?
Yeah. Okay. So if you want to find something to write about, so if the questions is if this project is something that you want to like write about on Towards Data Science, again, I firstly recommend using Kaggle, because on Kaggle you have this idea of data sets that are public and everyone can click on them, and Towards Data Science see them, the editors and the reviewers see straight away, and they're able to actually go back to the data set and say, okay, it is public, we're good, you can publish that. So the first thing that I will try to do is that one.
Okay, I have one more question, but I don't want to take others' time. So maybe if nobody asks, and then I can
I'll come back right back to you. But I got the last question from Shady that tells, the selection of topics that I write about. That's, for example, the new topics will attract more reads and views. Okay, so I'm not a big fan of the articles that attracts more reads. So if you look at my articles, if you look at the list of the articles that I wrote in that are the most viral ones, they're not like reverse engineering Will Smith's lap at the Oscar. I don't do stuff like that. That was funny. I don't do things like that to like catch the attention. Or, I mean, if we talk about machine learning, we talk about something that is really, really like it is something that it is used nowadays a lot. So you're writing about stuff that is new. You're writing about new topics. If you talk about machine learning, you're writing about new topics because you're writing about the hot potato. So you don't have to be smart and look for the best thing that you can think. Just write what you like, write what you're good about, write what you know stuff about, because people will point out the mistakes you do. I got edits that I have to do on a weekly basis because I do mistakes, of course. And so the first thing that you need to do is to be sure that you know what you're talking about, and I wouldn't think about what attracts readers. I would just write what I like to talk about.
Hi, Piero. It's Federico here speaking. Can you hear me?
Yeah.
Thank you for the presentation. It's very, very, very interesting. I have a question. How it's done, the final validation of your model? Say, in the first part, you're presenting your model, and then you're doing a sort of validation. That validation is done against the original dataset that you are using Syscan, I guess that this data, it's something like a Syscan, or you are using another NDT method to have a sort of test that is assessing if you really have damage or not. That can be used as a reference, because I think that that one is the juicy part for an engineering point of view, having tools that can detect damage or not. Thank you.
Yeah, no, exactly. I went quick about it because it is a really engineering question. So okay, the dataset that we use is a collection of A scans, and the A scans that we use are from a carbon steel pipe. So we monitored for a lot of months this carbon steel pipe, but the actual experiment was on a corrosion method. And as an engineer, you know that corrosion doesn't do this. So the corrosion was a phase shift. So we took the signal that weren't corroded, that were like sane, and then what we did was to add the damage as a tone burst. So now we have all the signals and the signals that are damaged. Then you use the OBS method, and you see that if the OBS method says that the signal is damaged in the good location, is a true positive. If it says that the signal is damaged in the wrong location and doesn't find the actual damage, it is the worst case because it is a false positive and not a true positive, but it could be both true positive and false positive. So so this is the way we did that. We did that, as you saw in the various area under curves. We added different kind of damages, starting from a really small damage, let's say 0.05, so 5% of the amplitude. Then we did 10, 15, and 20 in different locations. So now we have something that we can test in terms of the OBS and in terms of the GPR method as well. So the data set that we have was first sane, no damage. We add the damage as a turn burst, of course, with the right frequency, and then we started to run our models on that, the traditional method and the GPR method. Did I answer your question?
Yes, thank you very much. I hope to read soon the paper, if it's not already public.
Yeah, I hope to read the paper soon as well, because it is on review. Let's see.
Good luck.
Thank you. What do you prefer from your experience, hands-on articles or conceptual articles? Conceptual articles are hard to pass in terms of towards data science. If you don't attach code or you don't tell a story that is really interesting, it is hard to pass an articles on towards data science. So firstly, I recommend hands-on articles. Otherwise, I would recommend articles that actually say something that is really interesting to read. If you talk about conceptual articles, for example, backpropagation, you can do it, but they're harder to pass. So what I'm good at writing is hands-on articles, because if I don't write the code, I get bored. So I tend to write hands-on stuff. I have a more motivational philosophical question. This is Stefano. I understand that you love machine learning and running. What is motivation behind setting this goal for 4 articles per month? Well, first of all, as you may know that the algorithm has to recognize you, right? The algorithm that promotes like the recommendation system that is behind the articles and makes you earn money needs to know that you're an active writer. So this is the first thing. I actually started writing this for passion, and then it started to become a job. But for me, it's not really working. I say 4 articles per month because it means that I have 4 free times. It means that I can have 4 times during the month when I actually relax and write stuff that I like about. So of course it is for a practical point of view, because you get to be known more, but it is because I force myself not to properly work, but having a little bit of fun 4 times per month. So I force myself to, relax a little bit. Do machine learning, so learning while I relax, earning while I relax, but still relax. Because writing articles for me, it's like playing video games. It's not something that really takes me time. I mean, of course it takes me time, but it's not something that for me is like, oh fuck, I have to write these articles. It's not something like that. It is something that I really like to do.
Thanks.
You're welcome. So there was another question from Serdar.
Yeah, well, actually, I'm a little hesitate to ask this question because I don't come from a STEM background, so I may sound some stupid. That's why I hesitate. But in the this non-destructive testing, you said current signal, and we deduct the baseline signal from the current signal, and we see that there's a little bump there, there's a single one, so there's a damage. But when there are many different bumps, so the temperature just kicks in. I mean, the temperature gets mixed with the situation, right? If I understand correctly.
Yeah.
Okay, and the temperature is correlated with the current signal. Is that right?
Okay, so that was probably actually my mistake. So these are 2 different situations. When you have that the temperature is not really interesting in terms of the signal, it means that you do the first thing that you said. So you have the signal and you only see a bump. When the temperature is something that is important of the signal, you take your original signal, you take the baseline, and they are meant to be the same except for the damage, but they're not the same because they're maybe 2 different temperature, and so they're not the same because they're different, but they're different not because there is damage, but because it is 2 different temperatures. Okay, so you don't get only the damage part, that is the one that you want to see, but you get a bunch of garbage that you don't want to have in your signal. Did I answer your question?
Yeah, thank you.
Okay, you're welcome.
So, if no other question, actually I have a lot of questions, but maybe I will ask you next week to have a conversation. I'm really interested in the writing part because I'm about to starting. I already told you about it. And so I'm about to start. But okay, we will talk about maybe next week. But really, it was really a pleasure for both the first one and the second one. I think that was really interesting and also inspiring. I'm telling to all the fellows for this edition and also the past edition how it's important to, you see, take care of your not only social networks, but you see, writing stuff could be really useful for yourself to better understand,
Yeah.
also to the other people to know what you are doing, you see. And so I think your talk was really inspiring from this point of view. And so if I don't know if there are other questions. If not, I'm really thank you, Piero, and for this presentation, and also for your passion about it. We can see it from the screen, and stop. So
Okay.
guys, thank you so much, Piero. If you have any question to raise, you can ping Piero on LinkedIn or whatever. Sure. I'm sure he will be happy to answer you or to get in contact with you. And that's all. So have a good day, Piero. Have a good evening to all the other people coming from Italy or Europe. And see you next time.
Thank you so much. I typed my mail as well. So if you want to write me an email, or you can write me on LinkedIn or wherever you want, for real. Thank you.
Thank you.
Thank you, Peter.
Thank you.